Greetings and welcome to another installment of QuantSlob. This is 6 in our foundational series. This time around, we're going to close out our Introduction to Statistical Populations micro-series. Statistical populations, whether they be concrete, imaginary, or can be regarded as a superpopulation, are comprised of elements or units. These elements will possess attributes or properties or features. For our purposes, the terms are essentially synonymous. If elements didn't possess attributes, then we could just scrap the whole project and all go home. It is, of course, by the way, very common to use the term variable to refer to what we're calling an attribute, but for the time being, I'm going to deliberately avoid using the word variable. If you will, recall in part 1 of this micro-series, we used the gameplay of an upcoming or some game to illustrate an abstract population. For the sake of example, let's say that our game is some game between Football Club A and Football Club B, fierce rivals, I hear. By gameplay, we're referring to the totality of the action and environment on the field. And of course, with something like a soccer game or football game, it's easy to ascribe a vast collection of features. It's important to consider here that it doesn't matter whether this one game, for the sake of illustration, is upcoming or whether it's already been played, or for that matter, an element of an abstract population containing all possible gameplays of some game. For another example, let's turn to our concrete population of bolts created by our bolt-making machine, which has as its elements, of course, bolts. We can, of course, ascribe attributes to these bolts, and there is no restriction on the attributes that may be associated to a population's elements. We could, for example, have our bolts possess eye color, or an attribute that indicates whether or not a bolt is inhabited by a ghost. I thought I was kidding around there, but there's an important point here. We must enjoy great liberty in ascribing attributes to units. And an attribute can be almost anything. An attribute can even be a function of other attributes. With only very special exception, as far as QuantSlob goes, the attributes of elements within our population have assigned values that are fixed. This is true whether the units are members of concrete populations or imaginary populations, or if the attribute is nonsensical, like a bolt being possessed by a ghost. Within populations, among these fixed valued attributes, there are no probabilities, no random variables, nor anything that they entail, no expectations, no sigma algebras for that matter. Before closing out this micro-series, I want to offer some thoughts here. It is not uncommon in some disciplines, such as engineering and probability theory, that population elements in and of themselves exist transparently. It is the attributes or variables that take center stage. Oftentimes in engineering, the view is taken that observations are materialized through some system, a system. The actual elements are abstracted away and one focuses attention on the measurements, or what we would be thinking of as manifest attribute values. In probability theory, attention is not given to the articles of some theoretical experiment, but rather the sample space induced by the experiment, or if we prefer, the sample space that induces the experiment. And it can also be the case, just to point it out, that population elements themselves may not be really distinguishable from an attribute that they possess. For example, we can imagine a collection of all rational numbers on the unit interval inclusively. This would be imaginary, countably infinite population. And of course, the attribute of interest would simply be the value of the number. But for the excellent data scientist, it is important and very important to be easy and comfortable with the concept of populations and especially their elements. In applied research, everything starts and stops with the population and its elements. That is going to do it this time around. Thank you very much for tuning in. I really do appreciate it. And don't forget to stay tuned for more QuantSlob.